Hello everyone, welcome back to PMAT1100. Let's continue with section 3.4 in 3.5. I'm sorry. In this section, we will be doing more application on linear equation. Linear equation is the application of linear equation is very extensive. It's very wide. So we in this section, okay, even in this course, we cannot cover all the different area that relating to linear equation. Anything can be related to linear equation. It's even in physics, in biology. You will see linear equation even in accounting, in finance, banking, everywhere. Okay, so we cannot cover all different aspects of linear equation. Okay, so in this video I just give you several examples that I think that you will see very often in your real life. Okay, and I will be talking about some formula that is very popular too, and you see that a lot. I mean, you experience that, but you never know. You never know that you really using it. Okay, so let's get started. Okay, the topic for today is the section 3.5. Okay, so let's write it. So section, guys. So section put the topic right here. Section 3.5. So I'm gonna put over here application. Linear equation. In previous video, we already learned how to solve linear equation already. So application of linear equation is nothing but a word problem. I remember in that video, in previous video, I give you example of few example of word problem too. But today we're gonna we go deep into more word problem. Okay, even we cover the whole section today, but it's still not enough. Believe me, it's still not enough. That's why when you learning when you solve application of linear equation, okay, you have to use your logical thinking a lot. Okay, so doing application of linear equation is nothing but training your logical thinking. All right. But before I'm going straight to the example, I'm gonna give you a general approach, and I think that it will help you to solve a word problem easier. Okay. All right. So I'm gonna put over here general approach. Okay, general approach. Okay. So in order to solve word problem, application of linear equation, the first thing is that you must have a very well. Okay. Oh, why is I don't know why it's black. Okay. You must have a very well good reading comprehension. because this is word problem, right? So when you read it, you must be able to understand it. If you don't understand it, then you cannot set up an equation. And if you cannot set up equation, you cannot solve for the variable they're looking for. Okay, so you must have good reading comprehension. I mean, I'm sure that most of you is not immigrant, so I mean, I'm sure that your reading comprehension skill is very good. Okay, and I think I totally trust you in that aspect. Okay. Um, secondly, okay. So after you read the problem, right, you have to summarize. All right, you summarize important information. Okay, important information is given in the question. Okay, so I'm gonna put summarize important given important information. Okay, information. I don't know why I put informative. Okay. Okay. So after you summarize important information, you collect the important information from the word problem. Then you must be able to set up equation containing variable, okay, and this variable represent what you're looking for. Okay, what you find. What you are finding. Okay. Then the last step must be solve that linear equation. So this is the general approach. Okay, this is the step I often use every time I do word application problem. And I think that if you follow this step, it might help you some way somehow. I mean, some of you have different strategy. That's fine. I mean, as long you can set up an equation and you solve for that equation, then which is good. If you don't have your own strategy, then I think you should follow mine. Okay. All right. So let's jump to our first example. Okay. In this example, we will be using a formula. Okay. And this formula is nothing but a literal equation. Remember, when we talk about literal equation, it is equation contain multiple variable, right? So the equation I'm talking about is d equal to r times t. So I'm going to box them. D equal to r times t. Okay. What is d, what is r, and what is t? D represent distance. Okay. R is rate, but R is nothing but the speed. You know, in some textbook they put D equal S times T. Okay. Some textbook they put D equal V times T. It's the same thing. Okay. And T is time. Amount is the is time. So I'm gonna put just time. Okay. So this formula is so important. Usually you experience that. I mean, sometimes you use that, but you don't know. Okay, you traveling with your car, you driving your car, right? And then it say that in your car say that you traveling at 45 miles per hour. Okay, and you traveling for 2 hours. If you use this formula, you can calculate the distance, okay, the number of miles you travel with that information given. Okay, sometimes you use this formula and you don't know. Okay, you don't even know. Or every time, sometimes you say, okay, I'm traveling at 30 miles per hour. Actually, 30 miles per hour is actually, it comes from this formula too. Miles per hour. 30 miles per hour. I mean, distance over t is the speed. Okay, so when you saying that, when you say you're traveling 30 miles per hour, actually you're using this formula already. Okay, 30 miles per hour is actually is the way they write 30. The way they write it is based on this formula. Okay. All right. So let's jump to our example here. So this is the word problem. I'm gonna just go ahead write out everything. Okay. All right. Joy. Okay, Joy and Jack start from the same point. Okay, start from the same point. Okay. Okay. And walk in opposite direction. And walk in opposite direction. Here, Joy walk 2 kilometer, 2 miles, or let's use miles per hour, 2 miles per hour faster than Jack. Okay, here. Okay. They are 30 miles apart. And question A, how fast did they walk? Alright. So that's the word problem. How are we gonna do this? Solution. So I'm gonna put answer here. Okay. Let's use different color for answer. I think I'm gonna use let's see, we can use this color. Okay. Alright, so just imagine you had Joe and Jack start from the same point and walk in opposite direction. Okay. Joe walked 2 miles faster than Jack, and they are 30 miles apart. Okay, they are 30 miles apart after 3 hours. Oh, I missed that information. They are 30 miles apart after after 3 hours. Okay, and how fast did they walk? So they have Joe and Jack start from one point here, and one go this way and the other one go this way. Okay, the other one go this way. Okay, and after 3 hours, so this is the start. Okay, so this is start point. So after 3 hours, so this is start point right here. Joe is right here. Okay, Joe is right here, and Jack is here. Okay, and between them is 30 miles. Okay, so Joey walked 2 miles per hour faster than Jack. So how fast? So basically, they asking you the speed. Okay, the question asking you the speed of Joey and Jack. Okay, so I think I'm gonna name the variable. I'm gonna name variable x and represent for the speed of Jack. Okay, speed of Jack. Okay, I'm gonna call x represent for the speed of Jack. Okay, then what is the speed of Joe? Joey, because Joey walked 2 miles per hour faster. Then this is the speed of Jack, right? And 2 miles per hour faster, we need x plus 2, right? Because it's more. 2 miles per hour faster, then of course you have to add it to 2, right? Okay, so that's the speed of Jack. Actually, this is R of Jack. So I'm gonna put over here. I can put over here R Jack. Okay, and this is R Joy. Okay. All right. So we got R of Jack and we got R of Joy. Okay. If we multiply by the time, right, the amount of time Jack walking and the amount of time Joe was walking, then it give you, okay, it give you the distance, okay, of Jack, right? So the distance of Jack. So d Jack will be speed R of Jack, right? R of Jack is x time what? Time what? Time the amount of time they walk. So 3 hours. 3 hours because they walk 3 hours. Okay, they walk for 3 hours. Same thing. D of Joy will be what? The 3 hours, right? Because both of them walk for 3 hours. 3 hours. 3 times x plus 2, right? Okay, 3 times x plus 2. That is D. Okay, so after you got D of Jack, you got D of Joy. If you add them up, okay, because from here to here, is from here to here, is D of this is that from here to here is D of Joy, right? And from here to here, is D of Jack. Okay, and you see that from here to here, D of Joe, you feel here, D of Jack, you add them together, it gives you the whole thing, right? It gives you 30 miles. So I'm going to add both of them together. So I'm going to add 3x. Oops. I'm going to use this. Use this color again. Okay, I'm adding them. So I'm adding them up. So 3x. You add it to 3 times x plus 2, right? Then add all of them together, it gives you 30. Okay, see, I just successfully setting an equation contain the variable x, and variable x represent for the speed object. Okay, so from here I can solve for x, so I've distributed. Okay, distributed. So I will have 6x plus 6 equal 30. Then I will have 6x equal 30 minus 6 is 24. Okay. Then I will have x equal to 4. But x is what? X is the speed. So don't forget the unit will be miles per hour. Okay. So then what is the speed of Joe? Okay. So R jack is 4 miles per hour. Okay, and R Joey will be what? Will be x plus 2 will be 4 plus 2 will be 6 miles per hour. Alright, here you go. So that is how you solve the word application problem. You name variable, okay, and that variable represents what for what you're looking for. Then based on information you set up the equation and you solve the equation. Okay, so that's how you do it. Okay, now we're gonna do second example, and in this example we also use one of our literal equation, the formula we already learned last time, which is the formula of rectangle. Okay, let's see how we can use formula of rectangle to do this problem, to do the following example. Alright, so let's jump to example number 2. Example 2. Okay, let's see. Alright. Oh, this is a pretty long problem, so I don't know that I can hold on, let me have some space here so that I can put this one here. Okay, but let me turn this off. Hold on. Okay. Alright. So our second example look like this. An architect is planning a new area in urban campus. Okay. She wants the length to be twice the width. A new rectangle. I'm gonna put away. Is planning a new rectangle area in urban campus. She wants the length to be twice the width. To be twice the width. Period. And wants to put a 3 foot high and wants to put a 3 foot high wall around perimeter. Here there will be 309 feet of wall installed. Okay. How wide will this area be? So the question is, how wide will this area be? Alright, solution. Okay, so how are we gonna do this problem? How are we gonna do this? Okay, let me use let's see if we can use this color or not. So first of all, let's draw the picture, right? Because she's planning a rectangle area. So this is the it's very hard to see. So this is not a good color. I think we're going to use this color again. So I have a rectangle. Okay. And this is the width, this is the length, right? W and L. They're asking you this. Alright. She want the length to be twice the width. So the length is twice the width. It means the length L will be 2 times the width, right? L will be 2 times the width. So if over here W, over here will be W, and L is 2 times the width, so over here will be 2W, right? Okay. And there will be 309 feet of wall installed. So it will be around that. Okay, it will be around that. We mean perimeter, right? Perimeter. Okay. The 3 foot high wall is nothing to do with the problem because that's the height of the wall. Who cares? Because they asking you for the width. Okay, this from here to here, they don't care about. I mean, they put 3 foot, but we don't care about how high the wall is. Okay, so from here we know the formula is P equal to 2 length plus 2 width, right? Remember the perimeter of the rectangle, right? So that is the literal equation. So that's a formula. Okay, and they give you perimeter is 309. Okay, and the length is what? The length is 2W because they're asking you for W, so we have to find W. So the length is 2W. So we do have we have 2. L is 2W, right? Okay, plus 2 more W here. W, 2W. Okay. Then this is our equation in terms of W. So we're gonna solve it. So it will be 4W plus 2W. So we have 309 equal 6W. Then W will be 309. 309 divided by 6, right? And you will have W is 51. So with 309 divided by 6, it will be 51.5 feet. There you go. So that will be the width. Okay, if they asking you for the length, okay, if they're asking you for the length, then the length will be what? Over here they don't ask you for the length, but what if they ask you for the length? You just multiply by 2 because multiply by 2 because the length is 2 times the width, right? So 2 times 51.5, then will be 103. Okay, that is for the length. So over here will be 103, over here 103, over here 51.5, over here 51.5. Okay, so that will be the answer. Okay, so that is our second example. So on the test, okay, I can give you any problem, okay, relating to any word application. I mean, it could be related to any formula. So I can come up with anything. Okay, so your job, your responsibility is to figure out how to set up equation. Okay, of course I'm not going to give you something too hard, but I'm going to give you something similar to this. Okay, something similar to our example here. I try to give you more examples so that I have more option to design the test. Okay, all right, so that is our second example. All right. Now on the third example, okay, I will be talking about mixture. What I mean over here that I have one of the compound and I have another compound, then I mix them together, something like that, you know. And I'm asking you, okay, how many liter for the first compound, or how much kilogram, how many kilogram for the first compound, something like that. Okay, so this type of example we call that mixture problem. Okay, and the problem could be like this. Something like this. Hold on. All right. A company sell 2 types of grass seed. Okay. Mixes that are popular in its area. Okay, the first type we call a premium mix. Okay, and this type sell for $1.25 per pound. Okay, at $1.25 per pound. Okay, the second type, okay, we call standard mix. And this type sell at $1.95 per pound. Okay, right. Okay. Okay. All right. Okay, if the store manager started with 20 pounds of premium mix, okay, in a barrel. Okay. How many pounds of standard mix? The question is how many pounds? How many pounds? How many pounds of standard mix should be added to create a mix? Should be added to create a mix that could be sold for $1 per pound. Okay. Alright, so how are we gonna do this problem? This problem, believe me, it makes a lot of students confused. But it's not really that bad if you read it carefully and if you draw the picture. So first of all, we have two type of mix, right? Two type of seed mix. Okay. The first type of mix. Okay, I'm gonna draw something like this. Okay. So this is the first mix, and this first mix is this premium mix. The first mix over here, premium mix. So the store manager start with 20 pounds of premium mix. So this mix has 20 pounds, and the price is $1.25. Okay. Okay. So the thing is that this manager, they combine the premium mix, okay, with the standard mix, okay, with the standard mix. So this is represents standard mix, okay, and they asking you for standard mix, so I'm gonna name X representing standard mix, and this standard mix is only $1.95, okay, per pound. So you mix them up, right? Look at the read the word problem. How many pounds of standard mix should be add? Okay, so I'm gonna add them together. Should be add to create a mix. So I'm gonna add both of these together to create another mix. So this is another mix. Okay. And this another mix, this new mix is $1. Okay, so we're gonna add all of them together because they combine it. How many pounds of standard mix should be added to? Okay, should be added to. So I'm gonna add this to this to create this. All right. So over here it will be 20 plus 9 because you add them, right? You combine them. Okay. So that is the picture. Okay, it will help you visualize the situation, the scenario. The thing right now that we already know the variable because we already know variable x representing the standard mix. Okay, because they're asking you for standard mix. Next, we have to set up equation. So what equation? So we have 20 pounds of premium mix at 125 pounds. So the total of money for this premium mix will be what? Will be 20 times 125, right? That's the amount of money for premium mix. You add it to amount of money, okay, for the standard mix, okay, all right. Then it give you what? It give you the amount of money, okay, for the mixture. Right? You add up this, give you that, right? It's to this, give you that. So it will be 20 plus x time what? Time 1. Right? Time 1. Okay. So that's the equation. Okay, that's the equation. So this is amount of money spent on premium mix. This is amount of money spent on standard mix. You add them, it gives you the amount of money spent on this mixture, right? The final mixture. Okay, the final mixture. Alright, so this is the equation already, so we can solve it. 20 times 1.5 is 20 times 0.25. Let me see, 20 times 125. It gives you 25, so this will give you 25. This is 195x. This is time 1, so I'm going to just 20 plus x. Okay. So let's solve this equation. So we have we're going to subtract both sides by 20, so we have 5, right? And we're going to subtract both sides by 0.95, so 1 minus 0.95, which is give you 0.05x, right? Then in order to get x, what you're going to do? In order to get x, you're going to divide both sides by 0.05, right? So your x will be 5 divided by 0.05, which is give you 100. But 100 what? 100 pounds. Because x represents the amount of standard mix. Okay. So that will be our answer. That will be our answer for the question, because they ask you how many pounds of standard mix. So it will be 100 pounds. Okay, that will be 100 pounds. So the hardest part in this problem is that the equation right here. So you must be able to set up equation like this. Okay. Okay. So that is the typical example of the mixture problem. The mixture problem could have many different forms. You can mix one type of fluid to another type of fluid to get a new fluid, or you can mix many things. You can, let me see, for example, you can mix, let's see, where is that? I just see it somewhere right here. Or you can mix gas to water, or you can mix you can mix many type of things, but the way you set up equation will be the same. Okay, I recommend that you draw the picture like this. Okay, when you draw the picture like this, it will help you visualize, and it's easier for you to set up equation. Okay, it's very easy for you to set up equation. Okay, all right, so I think I'm gonna stop our section with this example. Again, I already said that linear equation can be in different type of application. So many different aspect of life uh, can be used with linear equation. Okay, so I cannot cover everything, but I hope that on the exam, on the homework I assign you, it will help you to be exposed to as many problem as you can, so that on the test you will be able to solve and set up equation. Okay, I'll be seeing you next time in the new video. Bye bye.